Hello students, in linear programming topic, another important, the last one is, the first one is formulation, second one is solution methods, and third one is primal and duality in linear programming. This is also very important for MCQs and even for short questions also. So what exactly is primal and dual? What is duality in linear programming? Every LPP problem, whatever presentation we are doing, the objective function, constraints, non-negativity, it has got an alternative way of presentation also. The same LPP can be presented in another form, that is only called as duality form. And ultimately, if you get the solutions either for the first primal one or the alternative one, ultimately the answer will remain same. So what exactly is primal? Primal is the original LPP what we are formulating. If you exactly transpose that LPP, then you will get duality. So what is duality is? Duality is an alternative way of writing the original equations whatever we are forming in LPP. So for every LP problem, that is linear programming, there is a related unique LP problem, that is another linear program involving same data which also describes the original problem. So we are going to use the same data, but only thing is in another form we are going to present. So what is that another form known as? That other form is only known as duality, dual program. So same data, but you are forming in a different manner. The equations you are forming in a different manner. So that is only known as dual. So the given original program is called as the primal program. This program can be rewritten by transposing. Transposing is nothing but reversing. So rows will become columns, columns will become rows. By transposing, nothing but reversing rows and columns of the algebraic statement of problem. Algebraic statement is nothing but equations. So inverting the program in this way results in dual program. So if you do inverting, nothing but that is transposing, rows will become columns, columns will become rows. So if you write in the form of equations, that is only your dual program. The variables of the dual program are known as dual variables or shadow prices of the various resources. This is very important. Shadow prices of the various resources. What is shadow price of a resource? It is nothing but opportunity cost. So if that particular raw material or the input, if it is not available, then what is the opportunity cost? Yes. So basically it is an opportunity only. Your dual program is based on opportunity cost, we will generally formulate. So let's understand this now. See this example. Our normal LPP, the original LPP, which we call it as primal, what we all know, the original one, this is called as primal. See here the objective function is maximization. You have two variables x1 and x2. Here x1 is having a coefficient of 10. So that is profit, let's take it as profit only, profit per unit. And for second unit, second product here, the profit per unit is 20. What are the constraints here? Subject to constraints, labor hours. Labor hours, what is the time required for first product is 5, for second one 3. And what is the total time available is 30 hours. So less than or equal to 30. Then machine hours, less than or equal to 50. So x1 comma x2 is greater than or equal to 0, non-negativity assumption. So this is your original program which is called as primal. Now what is dual? Dual is now the same primal can be written in this form which is called as dual. So what is dual is, if you make your input variables, if you make your input variables as the decision variables, then it will become a dual program. Okay, first let us transpose this. So what will happen in dual is, you can see these decision variables will become your constraints. Your decision variables coefficients will become your RHS. Okay, and whereas your constraints RHS will become the objective function coefficients. Okay, see, that is the reason these indications are given. Primal objective function coefficients will become constraints of dual. Okay, and original primal constraints will become objective functions coefficients. So this is called as transposing, reversing, right? And one more thing is, the less than or equal to equations will become greater than or equal to in our dual program. Whereas in primal, if you have greater than or equal to, in dual program it will become less than or equal to. Okay, and what we do is, the variables whatever we are taking here in dual, we are naming them as y1 and y2 here. So 30, which is a constraint quantity here, RHS of the constraint quantity, will become objective function coefficient here. Second, this second one y2, second constraint we are taking as y2, that is machine hours we are taking as y2. So understanding is very, very simple. So everyone can easily understand this. So now if primal contains n variables and m constraints, here how many variables are there? Decision variables 2 are there. And how many constraints are there here? There are, here you have 2 constraints. Okay, so here what will happen? Here also you have 2 constraints, here also you have what? 2 variables. Opposite. Now if you have here, in this 2, both are 2 only, but what if you have variables 2, constraints 3 in primal? In dual what will happen is, variables will become 3, constraints will become 2. Right, so that is what explained here. If primal contains n variables and m constraints, the dual will contain m variables and n constraints. Next, the maximization problem in the primal becomes the minimization problem in the dual. Yes, it becomes what? Maximization problem in primal will become minimization problem in dual, and vice versa. The maximization problem has less than or equal to constraints, maximization problem, whereas minimization problem has greater than or equal to constraints. Constraints of less than or type in the primal become greater than or type in the dual, and vice versa. The constraints which are having less than or equal to type, sign, whereas in primal they will become what? Greater than or equal to type in dual, and vice versa. So conversion of primal into dual. How to convert primal into dual? Let's take situation wise now. First, when objective is maximization. When objective is maximization, right? So when objective is maximization, all constraints, make sure that they are in less than or equal to form. Okay, if any constraint is in greater than or equal to form, what you do is you convert that into less than or equal to type. Now see here. Condition is, situation 1, objective function is maximization. Ensure all constraints in primal are of less than or equal to type. Make sure that all constraints in your primal are less than or equal to type. If you find any constraint with greater than or equal to type, convert that by multiplying both sides with -1. If constraints are of greater than type are given, then change its sign to less than or equal to by multiplying with -1 on both sides. Okay, let's take a question now. See, this is primal. objective function is maximization z is equal to 9x1 plus 5x2. Subject to constraints less than or equal to first one. Second one is greater than or equal to. So whenever you have maximization, constraint should be less than or equal to. Okay, so second one is greater than or equal to. So what we should do is, first we should convert this into less than or type, then we should write dual for this. So what we need to do is take the same thing. First primal only we will present here. Max z is equal to 9x1 plus 5x2 subject to 2x1 plus 3x2 less than or equal to 16. Second one, now multiply with -1 both sides. So this is the one. Now this, convert this into less than. Convert to less than type. So minus 5x1 minus 2x2 less than or equal to minus 20. x1 comma x2 greater than or equal to 0. Now we will write dual for this. So dual, what will happen is, your constraints will become coefficients of objective function. So let this one will be y1 and y2. Okay, then how to write dual for this? Maximization objective will become minimization in dual. So minimize z is equal to, now this we will take, y1 and y2 will be our decision variables. So what is the coefficients for this? Now 16 and minus 20 will become your coefficients of this. So 16 y1 minus 20 y2 subject to now your column wise will become what? Your rows. Your columns will become rows. So 2y1 minus 5y2 greater than or equal to, what you should take? 9. Next, second column will become second row now. 3y1 minus 2y2 greater than or equal to 5. And y1 comma y2 greater than or equal to 0, non-negativity assumption. So this is only dual for this question. I hope you understood. Now one might get a doubt, sir, why we need to write dual? What is the reason for this is? So sometimes what will happen is, number of constraints will be more. When number of constraints are more, your simplex method, because this we use in simplex only. See, now what happens is, when number of constraints are more, simplex problem solution will become more complicated. So that is the reason, in order to reduce the number of constraints, we'll use dual. First we will write in dual form, then we will get the solution for the dual. Because I told you that primal solution or a dual solution will remain same ultimately. The answer, final answer, the value will remain same. That is the reason. And what exactly is dual conceptually means here, I have to explain, going by this example now. What if, see, basically our inputs are becoming part of our maximization objective, part of our objective function. So we are saying minimization of our input variables. So basically, what if this labor and machine are sold outside? Instead of making x1 and x2, what if these raw materials are sold outside? If you know that these raw materials are raw materials can be sold outside, that means they have got some opportunity cost or not? Yes, they have got some opportunity cost. So now what I would like to do is, I would like to minimize that opportunity cost. What I would like to do, I would like to minimize that opportunity cost. So that is how you should understand. So that is the reason minimization. And now what you should do, with the minimum resources you should try to get what? Maximum output. With minimum resources only you should try to get what? Maximum output. So that is the reason it should not be less than 10 or 20. So with whatever, what will happen if you minimize your opportunity cost? What will happen is it will increase your profit. If you minimize your opportunity cost, what will happen is it is going to increase your profit. So that profit should be greater than or equal to 10, first case. Second case, it should be greater than or equal to 20 because of this input variables. So how to understand this logically is, think that input has got some opportunity cost. Inputs have got some opportunity cost. So labor and machine hours have got opportunity cost, assume. That means every labor hour has got opportunity cost. So that means somewhere it can be used somewhere else, or it can be sold outside also. So now in another form, how you can write is, from input point of view we can write this. So what I would like to do is, I would like to minimize this cost. Which cost? The opportunity cost. So and constraints, how you should understand is, with this the number of products, now products are becoming constraints now here. So what will happen is, now the constraints whatever we are using here should give you more than 10 or more than 20 profit in both the cases. So that is how you should understand. That should maximize your, so you should use this inputs in such a manner that should give you more than 10 or more than 20 profit here. So that is your dual program. That is how you should understand. So dual basically is from basically considered as shadow price. Shadow price is nothing but opportunity cost. So that is only logic here. So try to remember these steps. Easily you can understand. So here with maximization we have covered here. Maximization case we should know that all, first you make primal all constraints less than type, then easily you can convert them into, so less than type will become greater than type, isn't it? Yes. Now if you have a greater than type, then what you should do is, you should convert that into less than type by multiplying with minus symbol on both sides. Then after that you can write dual for that. Next, situation 2 is, if you have minimization objective. Minimization objective. In this case also, since it is minimization, all constraints should have greater than or equal to type constraints. In that, if you have anything less than or equal to, convert that into greater than type by multiplying with minus on both sides. Ensure all constraints are of greater than or equal to type. If constraints are less than type are given, change its sign to greater than or equal to type by multiplying with minus 1 on both sides. On both sides. See here in this example now, here minimization objective is there, 100y1, 200y2, subject to, so constraints if you see, first one is having greater than, okay, but second one if you see have less than here, third one is greater than, y1 comma y2 greater than or equal to 0, write its dual. So what we need to do is this, we need to convert to greater than or equal to. First you do that, then after that you can write dual for this. So primal minimize z is equal to 100 y1 plus 200 y2, subject to 20y1 plus 3y2 greater than or equal to 20. Second one, minus 5y1 plus 4y2 greater than or equal to minus 40. Third one, 3y1 plus 9y2 greater than or equal to 90. Okay, so now what we should assume is these three variables, constraints, will become decision variables. So this will become y1, y2, y3. So now if you write dual for this, minimization will become maximization. Maximize z is equal to 20y1 minus 40y2 plus 90y3 subject to see, already you have a y1, y2 now here. So what we will do is we will use x1, x2, x3, otherwise x1, x2, x3. (20x1 minus 40x2 plus 90x3) subject to this one, no. Columns will become rows. So 20x1 minus 5x2 plus 3x3 less than or equal to your coefficient of the first variable, that is 100. Next, second one, 3x1 plus 4y2 plus 9x3 less than or equal to 200. So your constants will become variables. Three constants have become three variables, and two variables original now will become two constraints. And non-negativity assumption, that is y x1 comma x2 comma x3 greater than or equal to 0. So this is dual for this example. So situation 2. I hope everyone understood now how to convert a primal into dual. Now see this one. When you have equal to, here, so equal to, you need not do anything here, only it is for greater than or less than. Now since it is maximization, what you should have less than on here, less than, but here you have greater than. So what we supposed to do? Convert into less than type. Convert into less than type first, then you can write dual for that. So non-negativity assumption is x1 greater than or equal to 0, x2 greater than or equal to x3 is unrestricted. x3 is, so x3 is unrestricted. Unrestricted means what? It can be negative or it can be positive also. So write its dual. Now first primal only we will write. Maximize z is equal to 3x1 plus 4x2 minus 2x3 subject to (4 x1 minus 12 x2 plus 3 x3 less than or equal to 12 minus 2 x1 plus 3 x2 plus x3 less than or equal to 6. Third one, 5 x1 minus x2, this we have to convert now by multiplying with minus 1, minus 6 x3 less than or equal to 40. This one will remain same, 3x1 plus 4x2 minus 2x3 is equal to 10. So non-negativity assumption is anyhow it is there, x1 greater than or equal to 0, x2 greater than or equal to 0, and x3 is unrestricted. So it can be greater than or less than also, x3. There is no restriction for that. Now, dual, if you want to write for this, dual, maximization will become minimization. So minimize z is equal to all these constraint quantities will become the variables now. How many variables now? y1, y2, y3, y4. So coefficients are this only. So 2y1 plus 6y2 plus 40y3 plus 10y4. Subject to subject to 4y1 minus 2y2 plus 5y3 plus 3y4 greater than or equal to 3. Next, minus 12y1 plus 3y2 minus y3 plus 4y4 greater than or equal to 4. x3 now, 3y1 plus y2 minus 6y3 minus 2y4 greater than or equal to minus 2. And non-negativity assumptions, y1, y2, comma y3 y1, y2 and y3 greater than or equal to 0. y4 is unrestricted. Unrestricted. y4 is unrestricted. So this is the dual for this question. So equality case also, I hope you understood how to handle this. So this is conversion of primal into dual. So basically dual is an alternative way of writing the original program. Ultimately the outcome answer will remain same for primal or dual. Only the presentation will change. I hope everyone understood this. So you might get this in MCQs or as a separate question also you might get this. Okay, thank you. So this is all. This is linear programming in 3 parts. I am sharing the videos. Part 1 will have formulation. Part 2 will have solution methods, graphical and simplex method. Part 3 will have this primal and dual. Thank you.